So hello friends, in this video we are going to learn about Norton's theorem. Now if you have any circuit and if you want to simplify the circuit, so you can replace the entire circuit with a one Norton's equivalent circuit. So what Norton's has stated, he has stated like if it is possible to simplify any linear circuit which contains dependent or independent current and voltage sources, okay, with one equivalent circuit. And what is there in the equivalent circuit? You will have just one current source. So you will have one current source like this in parallel with a Norton's equivalent resistor. So this is Rn. So you have, if you have any circuit, so you can just replace with a current source which is In in parallel with a resistor. This is this statement of Norton's. Now if we just redraw, if I re-illustrate the circuit, so it will look like this, right? Current source in parallel with a resistor. Now what will be the procedures that we require to follow while we have to solve any circuitry? We have to simplify any circuitry with the help of Norton's theorem. So first task is to short circuit the elements. So let's say if you have any circuit, say for example, if I have one circuit like this, 48 volt and then 12k, then 4k, 8k, and here if you have 5k. So now I am looking for Norton's equivalent across AB. So first task is to short circuit it. So in order to obey this first task, what I have to do is I have to short the AB terminal. So the newer version of the circuit would look like this: 12k, 4k, 48 volt, and this is 8k, and I have to short this two terminal. Okay, and then I have to find out what is the equivalent current which is flowing through this particularly short circuit branch. Okay, so this is the first, and this current is known as a Norton equivalent current. Now second, in the second task what I have to do is I have to turn off all the sources. So we have already discussed in the Thevenin's theorem that if we have current source, then we have to open it, because once circuit is open, then current is zero. And if you have a voltage source, then we have to short it. So after applying those two basic things with the sources, then the remaining part will be the passive elements, and that would be like resistors here. So here if I short circuit this 48 volt, so what will remain in the circuit is 12k and 4k, 12k and then 4k here, right? So 4k and then 8k. Now I have to find out the equivalent current across this. So this is my Norton's equivalent, right? So in first step, I have to short this two terminal like this, and I have to find out the current. In the second step, in order to find out the current, I have to open this, and across this AB terminal, I have to find out the current. So if we go further in detailing of step number 1, so what is there in this circuit is, this is 12k, and then when I short this AB terminal, this particular, this 8k start appearing in parallel with 4k. Okay, so I have to find out the equivalent resistor here. So what will be my equivalent resistor? If two resistors are in parallel, 4 into 8 divided by 4 plus 8. So it is 32 divided by 12. Okay, so this is my equivalent resistor. And in order to find out the overall current, this is 12k in series with equivalent resistor. And what is the equivalent resistor? 32 divided by 12. Okay, so current flowing through this particular loop is here. is nothing but voltage, is 48 volt divided by equivalent resistor. So now two resistors are in series, so I have to add them. 12k plus 32 divided by 12. So the answer would be like, what is I? So 48 divided by 12 into 12, so 144 plus 32 divided by 12. So 48 into 12 divided by 176. So this would give me overall current. So overall current will be 48 multiplied by 12 divided by 176. So 3.27. Now see, one thing here important to notice is that all the resistors which is given here, they all are in the kilo ohm. So here similarly I will have kilo ohm. So in short, whatever the things I will get in the denominator, this will be in kilo ohm. So finally, this will be in milliamps, because 3.27 into 10 raised to minus 3 will gives me milliampere current. So 3.27 milliampere current flowing through this. Now this C, this 12K and this branch both are same. So similarly 3.27 milliampere will flow from here. Now it has two paths. One is this I1 and other is I2. Now in order to find out the short circuit current is what? So the current which is flowing through this 8K and through this. So I am looking for this I2 current, and this I2 is nothing but my Norton equivalent current. So in order to find it, the opposite side resistor, which is 4 divided by sum of 2 and into this equivalent current, which is 3.27 milliampere. This will gives me Norton equivalent current. So this will be 4 divided by 12 into 3.27 milliampere. So this is nothing but 1/3 of 3.27 milliampere. Okay. So in this way you can find out the Norton's equivalent current. So in short, you have to short it. Then whichever theories you know, like here you require to make them in parallel. Then you have to find out this current first. What is my current? Then you have to apply the current division in order to find the current. Okay, here and of course while you apply this Norton, so this part will be shorted, right? So you have to find out this current, and once you have this current, this is Norton equivalent current. So this you have to represent like this, and in order to find the current, the equivalent resistor, you have to apply the same theory. Like what will be the resistor here? You have to make this voltage source in a short circuit condition, so the circuit will be like this. So here 12 in parallel with 4 and in series with 4, 8 ohm. So here this Norton equivalent will be nothing but sum of 8K plus parallel combinations of 12 and 4K. So 12 into 4 divided by 12 plus 4. So this will gives me 8K plus 32, sorry, 48 and 16. So this will gives me 8K plus 3K. So it's 11K. So this